Okay, so now the essential question, the question we're wondering is what are some of the characteristics of the graph of an exponential function? So up to this point, we've been doing linear functions, straight lines. And now we're doing exponential functions, and we'll look at the characteristics of it. One key word that you can probably see is the word exponents is in there, so we're going to be dealing with how to graph with exponents, right? Okay. So let's look at two examples to kind of illustrate this point. It says, does each table represent a linear or an exponential function? Explain. So let's do that. So looking at this first one, if we go from 0 to 1, it increased 1, so plus 1. If we go from 1 to 2, it increased at plus 1. And if we go from 2 and 3, it increased at plus 1. So x increased 1 every time. And then look at the y values here. It went from 2 to 4, increased at a plus 2, from 4 to 6, plus 2, and from 6 to 8, plus 2. So there's this constant rate of change. There's a slope. And when there's a constant rate of change, we say that it's linear. If we were to graph this, it would form a straight line. It wouldn't be curving. Okay, it's a linear function. But let's look at this other one and we can compare them. So here, as x is increasing by 1 every time, right? Plus 1, and plus 1. Y is not increasing by a constant rate of change. I mean, it goes from 4 to 8, then it goes from 8 to 16, and then from 16 to 32. And so it's not increasing by 4 every time. So this is what we call an exponential change. And it's when the y value, the x is still changing at a constant rate, but the y value is changing by a multiple of a number this time. And so if we see that you were to multiply the 4 by a 2, you would get 8. If you multiply the 8 by a 2, you get 16. If you multiply 16 by a 2, you would get a 32. So what we're doing each time is not plussing, but we're timesing by 2, timesing by 2, timesing by 2. And so if you were to graph this, it wouldn't be a straight line. It would be nonlinear, it would curve. And this is why it's called exponential, because it's as though there's an exponent to the y value. It's being multiplied by 2 each time. Okay, another way to look at that is the exponents here. Evaluate each function for the given value of x. So looking at this first one here, if I were to substitute a 3 where the x is, and that would now become to the third power. By the way, I want to talk about a mistake really quick that sometimes people make. When you substitute the 3 in, that's good, but don't make the mistake of having the 3 go to both the 5 and the negative 2. That would be written like this, negative 2 times 5, right? It only would go to what the parentheses is touching, next to the parentheses. So when you substitute the 3 in, it would only go to the 5. And then you do the normal order of operations. So looking at this here, if we were to rewrite it, y equals a negative 2 times 5, and then that x becomes to the third power. Well, 5 to the third power is 125. Bring everything else down. And then a negative 2 times 125 would be negative 250. So if you input an x is negative 3, your output would be negative 250. Let's try it again with this one. This one's a little trickier because it's using a decimal, but it's the same idea. I want to review really quick how to convert decimals to fractions because I think it's been a while for some of us. And maybe later on I'll show you how to convert a fraction to a decimal. But so this would be called 5/10. And so one way you could write it is 5 over 10 because this is the 10th place value. And this would be the 100th if the decimal was here, and so on. So 5 over 10. One way to remember it is how many times would this decimal have to move in order to have no numbers in front of it? It would move 1 time, so there's 1 0. Okay, so 5/10 could be reduced though, because 5 goes into 5 one time, it goes into 10 two, so it's the same thing as 1/2. So 0.5 is actually the same thing as 1/2. So y equals 3 times 1/2, if that helps you. And then x to the negative second power. Now, if it's a negative power, then you would always go in the reciprocal, right? Any negative power does the reciprocal. And so it would be y equals 3. But since we're doing the reciprocal, it would, and then you could create it as a positive. It would be a 2 over 1. But we can just write 2. And then it becomes a positive power. And 2 to the second power is 4. So y equals 3 times 4. And 3 times 4 equals 12. So y equals 12. Okay, it is your turn to try this. Try this 6.3a. Go ahead and try 1 and 2. And I would like to go ahead and do 3 and 4 with you. And then what I'll do is I'll pause it and let you answer the questions. So y equals 2 times 9 and then to the x. But we're saying instead of an x, we want to put in a negative 2. So y equals 2 times 9, but the negative 2 power. So again, we have to remember that when anything's a negative power, it goes to the reciprocal. So it would be y equals 2, and the reciprocal would be a 1 over 9 squared, or 1 over 9 times 9 would be 81. And then 2 times 1 would be 2 over, 2 over 81. Okay, so we substitute the negative 2, and now let's try the 0. So the same thing, y equals 2 times 9 to the 0 power, but anything to the 0 power is just a 1. So y equals 2 times 1, and the identity property of multiplication would tell us that 1 times anything is the same number, so y equals 2. If you substitute in a 0, you end up with a 2. Let's do one more. It says if we substitute a half in. So let me see if I have room. Y equals 2 times 9 to the half power. And we'll remember from before that the numerator of this fraction deals with the actual power you'll put it to, and the denominator deals with the index. And the radicand, of course, is the 9. So we're basically asking for the square root of 9, which is 3, to the first power, but 3 to the first power is the same thing as 3. So if we remember all this, let's go back to our equation here. Y equals 2. We did all this to find out it was 3. So y equals 6. Okay, let's try it again with the second one here. It says y equals 1.5 times 2x, and it wants us to substitute in a negative 2. So y equals 1.5 times 2 to the negative 2 power. And it looks like we are running out of time. So remember, this would go in the denominator. It would be a 1 over 4. So y equals 1.5. Try to sneak this in. Times a 1 over 4. And then if you want to convert that to a decimal, y equals 1.5 times 0.25. I'm trying to hurry. You can get a calculator and multiply those and get your answer for the first one.